Well, now I'd like to turn to Seth Newman, who is going to talk to us about signaling that he does on his model railroad. Seth, I really do appreciate you doing this and looking forward to it.
So I'm going to give a little discussion of signaling, some stuff I've done with my company. I've used a lot of these techniques on my layout, and these items that I'm talking about all kind of arose organically with my late business partner and I. We were working on a number of people's layouts, and as we uh, we're doing signaling for other people, we came to some conclusions about, what we like to work with ourselves and develop some products to offer based on that. So real quickly, I've talked about model railroad control systems before, um, but we're all about, putting cool electronics for operations in people's hands. And an awful lot of this has been developed by other people who are, not necessarily interested in running a business in the hobby, but they are interested in sharing. So we put these products up, charge, just a minimal markup to cover the costs and offer them to other modelers. Uh, I also cover some commercial products so you can get it all from one place, or if you're particularly offshore and would like to minimize shipping, you can with one international shipment. And there's also people who just want one throat to choke, so try to offer everything together so there's no question about where it came from. Um, and we do a number of things, but I'm going to focus on CP node, which are Arduino-based CMRI nodes and components that are used in signaling systems. Simple signals and accessories, and we also handle some modular signaling system products, all developed by MSS guys. So we're not trying to tell them how to, do their segment of the hobby. And train order board and CTC parts. We'll talk a little bit about switch motors, which we also do. And then there's a bunch of other stuff, and I'm always happy to talk to anybody about this offline. Jim's give us the opportunity to talk about that in the past, so I won't bore you by repeating it. But when we talk about signaling systems, there's kind of three different things that modelers generally want to do. One is automatic block signaling systems, and known as ABS, and it's fairly simple signaling that the railroads brought in around the turn of the 20th century, and it provides protection from collisions. Dispatchers are mostly there to protect you from running into opposing trains, but they don't really have much ability to prevent you from running into the guy ahead of you. And you think of Casey Jones was kind of a famous crash like that. His train, a train ahead of him was stopped, I believe due to weather problems, and the flagman couldn't get out and stop him in time. So signals will tell you that there is a train 2 blocks ahead, 1 block ahead, and that you should slow appropriately. Now, ABS does not give a train authority to occupy the track. It's simply a safety overlay on top of timetable and train or track warrants, depending on your era. It's used on single track, and it can be used on double track with current of traffic, where you've got one-way signaling. And, a lot of your double track mains, particularly in the East, work this way. An interesting thing that not everybody knows is that most cases in ABS, you can pass a red signal at restricted speed after stopping, assuming you have authority. So if you had a run order, run extra from Alpha to Echo, and you come across a red signal at Charlie and you don't know why, after coming to a stop, you can proceed at restricted speed so that you could stop in half the distance to an obstruction. Full CTC is probably what most people think about when we're talking about signaling. It's Rule 261, which is basically interlocking rules. And really the way this is done is that each end of a CTC siding, and we'll cover this in a little more detail, is a very small interlocking plant where the signals are absolute. That means red means stop and stay, and you can't move unless you get a more favorable indication. Flashing red or yellow, you'll be restricting our approach in most cases. Uh, and of course, interlocking plants and towers and crossings are all part of that. Um, See, and then the third thing is train order boards. So they're semaphores, but they don't actually control traffic. It's not a stop and go signal. It's a stop and pick up order or slow down and pick up an order on the fly signal. And you can't pass a red train order board without getting a clearance. So typically you'd get a new order and that would have a clearance with it. Or if you're stopped accidentally, the operator would give you what's called an operator's clearance so you can continue. Um, Apparently, you weren't really supposed to do that. And if you read Josserand, who is kind of the rules book guy, you'll see that apparently people were doing this a lot because he must say a dozen times, this is really bad practice, you shouldn't do it. And you wouldn't have to repeat that if people weren't doing it all the time. There is a hold order. Anyway, so let's talk about ABS. This is fairly common. You'll see here I have a train in the middle. Can you all see my cursor, Jim?
I can't.
Yes, I can.
Okay,
Oh,
great.
yeah, okay.
Super. All right. So I'll kind of use this as my little red laser pointer, right? And you can see here that the train has got signals on his right, and there's clear track ahead. He's got a green and a green. But immediately behind him, the signal goes to red, so you can't enter the block, at least without stopping and proceeding slowly behind him. And the block behind that has gone to approach, which means enter the block, prepare to stop at the next one. And behind that, there's a green. So that's your typical 3-aspect route signaling. It's your basic Western signaling. Now, you notice that the opposing track, it's not really double directional because you could get to a situation where a second train was here facing a red and you'd have two trains nose to nose with red and somebody would have to back up. There were some enhancements later, but they're not modeled that often. Another interesting thing is notice there is no entering signal at the siding. The siding is kind of out in the middle of the block and you're free to enter that. So the crew knows based on their track warrant or train order that they have no authority to be on the main or that they need to meet someone, and they just take the siding and realign behind them. The siding isn't detected. The dispatcher has no way of knowing if anybody's in there. But this works fairly well, and for light traffic lines, particularly if there's no passenger traffic, this is still very popular. So depending on your prototype, it's something to model. And if you like signals and you think they're cool, but you don't really need full CTC or your prototype didn't have it, this is a very neat thing to do. Modeling, it's pretty simple. Couple of approaches, simple hardware solutions. This is a little device a friend of mine named Dennis Drury developed, and as you can see, it's just a little circuit board, no computers to boot up or anything, and it looks at detectors and lights up signals appropriately. There's also the modular signaling system, which is obviously, it comes from the modular community, and it basically does the same thing, little different electrically under the covers, but it's the same kind of idea, very simple signaling, plugs together with modular jacks. They have a non-prototypical aspect for handling diverging routes, which works very well for modular setups. So they've kind of modified the rules a little bit to meet their needs as modelers. And another approach is just to do it with an Arduino. So that's a little bit beyond the scope of this clinic. The other approach is to just do it with a computer, is just a very simple signaling system with computer control. I'd strongly suggest using JMRI, but there are things like Railroad and Company proprietary layout control programs. And if you're using CMRI, Dr. Chubb wrote some excellent basic, and he actually has excellent books. And if you're seriously interested in getting into signaling, even if you don't want to use CMRI and you have no interest of doing it in the basic language, it's still worth reading because the content, in terms of what the rules are and what you're trying to achieve is very good. And the basic is very easy to understand. So even if you're going to code it in some more modern language, it's a good thing. So I have a dog in the fight here. I offer CMRI compatible nodes that mix and match with other CMRI. I think it's a nice solution. It's powerful enough to do what most modelers need and fairly easy. But there are other layout control standards such as LocoNet, LCC. You can do it on DCC with things like NCE's AIU, which is an input board that can read detectors. And then there's an upcoming standard called MQTT, which is based on the Internet of Things, which is all your smart appliances and stuff. And guess what? A model railroad looks an awful lot like a home automation system. So the benefit is that this stuff is, widely used, inexpensive, and getting cheaper by the day. So that's always nice for us. Okay, so let's talk a little bit about CTC. As I mentioned, the ends are little interlocking plants, and you can see this is your classic triad that you've undoubtedly seen out rail fanning, where there's an entering signal with two heads. The top one regulates movement onto the main, the bottom one into the siding, and then there's a leaving signal on the main and on the siding. And the little charts below are just telling you how many lines of I/O or bits you need to control each end. And guess what? It works out that each end is about 16, which is a nice power of 2 and very easy to handle. We used that form factor because our idea, Chuck and I, was that we didn't like crawling around under the layout very much, so we wanted all of our signals and motors and detectors to be able to connect to something close. And we built a node that was small enough and cheap enough that you could afford to drop one off at each end of each siding. Dick Bronson with RR Circuits, who does LocoNet compatible and LCC compatible nodes, uses a similar approach. So this is a very good way to simplify your wiring. Let's see, modeling it. I would strongly suggest using JMRI if you don't already have, an investment in time and effort in something else. Dr. Chubb wrote some very nice basic for that could be used with CMRI, and it does give you an awful lot of control, but JMRI is now mature enough that any of its tools, control panel editor, layout designer, or CATS, will do most of the things most people want to do. And again, you can contact me offline if you have specific questions about that. Hardware for communication. We kind of talked about this above. There's several different ways to do it. And in all but the most extreme cases, any of them will work fine. And anybody who's reasonably familiar with what they want to do can get JMRI and any of these control systems to work pretty well. It's not a question of one of them will give you nirvana and the other are gonna just, derail you instantly. So, lots of options. The most important thing is being careful about your wiring. If you have bad wiring and a lot of electrical noise and those kinds of problems, probably nothing will work very well. So what's in a signaling system? The signals and the signal controllers, detection, current detectors for block occupancy, optical detection for point detection, switch motors and controllers, control panels, and connection points, what I referred to earlier as the node. And let's see. People always ask this, I'm just going to put this one chart out front. Where's the money going to go? Probably half of it, it's a little hard to read because the labels are tiny here, but signals. Signals will be two-thirds, a third to two-thirds of your total cost. Signals are like anything else. You can use shake the box stuff, very inexpensive but functional, or you can, build high-end resin kits or buy things from people like Scale Trains or Genesis or Rapido, and they're going to be a little more money, but they're going to look very nice. Detectors will probably be half of what's left. Detection is important. It's got to be rock solid for operations. You can get away with a little bit less for display running, but even then, in most cases, in a club or a museum, you want it to be reliable, so it's not a good place to skimp. Oops. What else? Motor controllers. I'm assuming you already have switch motors. Those will, add some cost. And finally, the backbone, the nodes, are going to be around a quarter to a sixth of your cost. So that just gives you an idea of what we're looking at. And we'll run through these quickly. Detectors, for your main, and this is true whether you're using a simple hardware controller for ABS or a computer. The current detecting block detectors are just the most reliable. There are other approaches. Most of them are a little more sensitive to noise and bad wiring, but you want this to be rock solid. They do require resistive wheel sets on each car for best performance, but for display running, you can get away with just the engines and a caboose. Lit caboose or passenger train works fine. Again, I really like the tombstone style detectors. I show an example here of my detector, the CPOD, but there's plenty of other good tombstone detectors. Again, our circuits makes one called the BOD8, which is an 8-channel one. Iowa Scale has a nice one. Dr. Chubb's original DC COD is, it's not necessarily the best, but it's very good and well known. So I would say it's kind of the reference standard. Optical detectors are very good for point detection. Some people use them for switches, OS sections. Prices are all over the place. Jim, I think you might be unmuted there. Let's see. One I really like is the TCRT 5000. It's a little emitter detector pair, and you can buy these in modules. This one's a fairly expensive one from SparkFun, but if you go out on your favorite Asian marketplace, you can probably find these for about 25 cents a piece. The one problem is that the detector head, which is over here, you may have to unsolder it and stick it up between the ties. But it's kind of big and visible, and I think it's pretty ugly. But for hidden track, it's great, and I love them for making sure that an engine hasn't stuck its nose out a little too far in hidden staging, or for following progress in a helix. So these are really nice, and the price is right. Some people have tried to gang a bunch of them together to get some of the benefits of current detection, but honestly, Murphy says 2 cars will just happen to be coupled right over the detector and won't get detected, and you'll have problems. So don't do that. Switch machines, lots of different kinds of switch machines, stall motors. You can use your existing DCC stationary decoders. JMRI will talk to your DCC system and control them. If you're controlling it directly from the computer, Dr. Chubb had a 12-channel decoder or switch driver called the SMC12. I make an 8-channel version. We also make little boards that stick on or next to your controller called the remote switch motor controller and the intelligent switch motor or turnout controller, and a very brute force one that works with CMRI. So all depends on what you've got available, what you're comfortable with. Servos are very popular. Generally, they need a little Arduino to control them. I have the MP motors. Those can be controlled with the uh, RSMC or the ITC, or just a little Arduino relay, which are incredibly cheap. You can get these in 1, 2, 4, 8, and 16 channels, and at the high end, they're well under $1 a piece. And then twin coil machines, and these range from very simple ones that Pico and Kato offer to the old nasty Ken Kidder ones. And I have a twin coil driver that I built for a client who had a lifetime supply of big ugly ones, but honestly the costs were such that he probably should have just bought some tortoises. And let's see. Then there's the backbone of the system, how you tie this stuff together. And I use these little CP nodes, which are CMRI nodes that are just chained together, and they each have 16 inputs and out, or 16 IO lines, inputs or outputs. And you can use those for your control points, and you can expand them in increments of 16 up to 144 lines. So could be a very fancy yard throat with a tower, or just, a simple unexpanded one for one end of a siding. It uses a little processor here. You can see it's plugged in at the bottom here. This replaced a board we started with, which had become unavailable, and we just built one with an Arduino Pro Mini. And here's the little Pro Mini plug-in. I am planning to build an MQTT plug-in for it also, so you'd have that migration option in the future. Here's a cost-reduced one that just has the Pro Mini on it, and it just, very simple, it just does CMRI. We'll probably never do anything more, but it's perfectly good for most applications. And if you just want to add a little node to your existing CMRI system, or just drop a bunch off at sidings for, single track railroad sidings, it's perfect. Oh, we also make optical, current detector motherboards if you like to centralize them. We have a decentralized version also. So all these are architectural questions, and it comes with how your layout is laid out and what you're comfortable with. Here's a little picture that just shows our whole product line. Not quite up to date, but pretty close. So got a lot of different pieces to fill in various needs. I make a line of adapters that plug into the classic Chubb system, and these are for wire management, various odd little cases you may have. If you don't see what you want, get in touch. We may have made it and never cataloged it, or probably could make it if you want it. So, and I can do these at surprisingly low volume. So just get in touch if you want one. Last case is train order boards. And this is great. Many of you are probably thinking, well, I have a dark railroad, it's just a mining railroad or a low traffic narrow gauge branch, and I have no need for such a thing. But you probably do have order boards, because most of these in the day were dispatched by a timetable and train order, and you had to have some way to tell crews where they needed to stop and pick up orders. So, usually these were semaphores, although you see more modern ones with color light or searchlight signals. And, it goes way back to ball signals. That's where high ball comes from. I got a high ball, that's my green signal. Control panels, they can be as simple as a couple of toggle switches, and you can get very fancy with them and emulate prototype hardware. I offer a little servo controller that will control a pair of semaphores. And they look like this. I mean, here's the little control panel. You can see it's nothing but a circuit board that could stick through your fascia, or a little control panel with labels. And on the back, it's got a power jack and resistors to control power to your signal lights if you're using lights, and the appropriate connectors. And we make a very simple, inexpensive signal to get started with. Talk about that in a moment. Here's the servo controller. You can see if this thing is designed to be mounted vertically. I've got it horizontal because it shows better in the slide. under the semaphore, and this would run a two-arm train order board. But you can turn those horns around and do the two signals facing each other at a block boundary in ABS, depending on what your prototype had in your era. So that's a nice little option. And signals, you have lots of new inexpensive options that we didn't used to have. Signals are models too, and the high-end ones can, comparably track the price of freight cars. So if you've got, Baltimore and Ohio color position lights, those can get up there for good ones. But, and that's where the signals could dominate the cost of the system. For low-end ones, we offer these little starter kits. They're just PC boards with LEDs on them. And these are great for signal repeaters. They're great for experimenting. They're great for putting up on a layout under construction. You don't mind if scenery gets all over a $2 signal like this that you can just snap another one off the panel and replace. But you wouldn't want to wreck a, $30, $40 signal. We have a new supplier on eBay who I've really gotten to like. He's called We Honest. It sounds like a joke, a little Chinese guy calls himself David. We Honest Signals. But he makes the low end. They're a little crude, but they do look like a signal, and they're between $5 and $9 depending on how many heads, and maybe a little more with a cantilever bridge. And he offers these things. And then he makes a higher end one that's very fine, has very nice detail. It's not quite accurate for Union Switch and Signal or GRS, but it's pretty close. And, it's still half the price of a real model signal, and it looks good, and nobody but the signal geeks will call you on it. So, and he's very helpful. So I would suggest browsing the We Honest store on eBay and seeing if David will make you what you want. Now, in addition, there's some beautiful, what I would call prototype signal kits. Showcase Miniatures just makes some exquisite little models, but they are craftsman kit and they're fiddly to assemble, and feeding the fiber optics through and lighting them are not for everybody, but they build up into gorgeous kits that are just exactly right. Atlas has the old BLMA line, plus the New York Central guy they bought the signal controller from has the New York Central style cat face type G signal. Tomar made beautiful signals. There's been a whole bunch of custom guys, and I don't list them all here because, they tend to go in and out of business, and I don't want to send you to the wrong guy, but if you want to nominate somebody to me, I'll put them in the slide for the next time. And again, prices are kind of all over the place depending on how complex it is, how many heads, so on and so forth. And, this can dominate your system. But, if you don't want to spend that kind of money on signals, there are quite acceptable alternatives for a lot less. Here are some references, my website, Bruce Chubb's manuals, RS-485 is a communication standard a lot of these systems, including mine, use. I have a list of vendors and open source people and my website, and what can I say? If you don't see what you want, ask. So with that, any questions? Have I put everyone to sleep?
Muted, Jim. Muted. There you go.
I'm a new guy to model railroad. And I'm going to have a small layout. Don't know anything about signals. So how do I determine where to put signals, how many signals, and so forth? Can I call you? Who should I talk? How do I get this information?
Well, give me a call is a perfectly good place. There is a signaling list. It's more people who are interested in prototype signals, but they're quite willing to help new people out. Generally signals are done in blocks. A block is usually around 1 to 2 train lengths long in model railroading. As a rule of thumb, I'd say take your longest standard train, multiply it by 1 1/4, and that's pretty much your block length. And interestingly enough, that's about what the railroads use on high traffic lines. So if they're running 2 mile long trains, the block will be 2 to 3 miles. If it's a low traffic line, they might stretch them out a little bit just because there's not that much traffic for them to meet, but that generally works. And if you're just doing ABS, then the question is, where are the sidings? And you just try to arrange the siding so that the block is towards one end of the siding, and then you'll allow a block or two between sidings, rinse and repeat. And for, I don't know, 10 or 12-foot train, then that says I'll have a 15-foot block. I have a 15-foot long town with the siding, 15 to 30 feet between towns, so a block or two, and then the next town and so on. And that's pretty simple, and that would be, up to a medium traffic railroad, a real railroad that was running more than 20 or 30 trains a day. You'd start to see them moving towards either double track if it was an older railroad and already had the double track, or CTC. And then the siding length is kind of a question of how many places do you want to meet. But realistically, a model railroad that's fairly long and designed for mainline running and dispatching, someone like Tony Custer or Bill Darnaby would have 6 sidings that were, a full train length long, typically 2 train lengths between them. And for a 20-foot train, that works out to about 60 feet per town, or 1 square mile. And those guys would have 7 or 8, 6 towns plus an extra block at each end. And that would be a pretty good size railroad. That, gives you an idea of the scale. Does that help?
Yeah, it does. Let me ask you this question. I just don't have that kind of space. I got a fairly small space.
Yeah.
I'm thinking about maybe a shelf switching line along one of my walls in a bedroom, that kind of thing. Do I need signals?
You might not. You might not at all. And that's kind of the beauty of um, a train order board. You might be running a low traffic branch in the transition era, and all you'd really want is a train order semaphore in front of the depot at the town you go in to switch. You might also build a little interlocking tower where it's crossing another line, and then you'd have some signals controlling that crossing, but the traffic is simulated, or maybe just a little bit of traffic because that crossing is going to end up in the aisle. So those are some ways if you want to use signals to provide a little more railroady flavor, or to add some interest to operations without having to go to the whole length of signaling the whole railroad.
Gotcha. Thank you so much. Anybody else have any more questions for Seth?
Yeah, Seth, this is Phil at home. So one of the things that kind of, I think people who got to look at signaling don't understand is there's a pretty significant cost structure when you do a siding. So if you do a siding with 2 turnouts, you have 3 signal towers at each siding, right? 2 for each direction, coming in, and 1 on the other side. So, it's kind of, it'd be interesting to walk through it and kind of understand. So something like that, by the time you get done, how much do you have into it? Not including the track work, what you think of as the traditional track work, the DCC, all of that's done. To add signaling in for those 2 sidings, what are 2 switches in the sidings? What would you typically be looking at?
Well, assuming you've already got switch motors on the main,
Right.
Probably around 200, maybe
okay.
30 with the motors, depending on what style of motor you want and so forth. But yeah, I think that's a fair number. So, you know, you could say one sound equipped locomotive, I could do a siding.
Right.
Yep.
But so it's probably, you know, if you took your turnouts on your main line and figure somewhere around $100 a turnout is what it's going to cost to do CTC with signaling and signal towers, et cetera.
Yeah, 100, 150. Again, you know, there's,
Right.
depending on exactly what you want to include, but something in that range, yes.
And that's why cheap people do narrow gauge.
Well,
Sorry, Seth. I'm just teasing.
yeah, and then you can take all that money you saved on signaling and buy Blackstone locomotives. So.
Right, exactly. No, I'm teasing. I'm teasing. It's just,
No, you're absolutely right.
anyway, I thought it was funny, but it is I've come to the conclusion there's a lot of expense there. There's a lot of pieces that add up by the time you get done with, you know, the detectors, the input output circuitry that you need. You know, the computer itself and monitor is actually not a big expense.
No,
But then, you know,
because
you add on the
don't
signal
want that.
towers and,
Yeah,
you know, et cetera, it adds up.
you do, and that's what makes, you know, things like My Simple Signals, Digitrack says something similar. You can do it for less, it doesn't look great, but then, you know, you can go out and use somebody like We Honest, and now all of a sudden you have something that doesn't look embarrassing that
Yeah.
won't break the bank.
Cool.
And you know, so we're very blessed to live in this era.
That's true. Anybody else have any questions for Seth? Seth, thank you so much for coming back and talking to us about the signaling. I really do appreciate it.
But you're welcome. Glad to be here, and thanks for the opportunity to share.
Yes, sir. Thank you so much.